Hello everyone, welcome back to this video. So in this video we are going to learn about DSA algorithm in Java. DSA is a digital signature algorithm. So it is an asymmetric key cryptographic algorithm and it is primarily used to generate digital signatures. The main purpose of DSA is to create and verify the digital signature in the information. So digital signature basically is used to ensure the authenticity, integrity and non-repudiation of a digital message or in a document. So in digital signature, a private key is used to sign a document or an information, while as public key is used to verify the signed document. So without too much delay, let us implement our DSA algorithm in Java. So to do that, I have already created a DSA package. So onto this package, right click and create a Java class called DSA example. So in this class, we will implement how to use DSA algorithm. So this is our main class, and under this class we will create our main method, and let us ask for a user input so that we can create our digital signature for that input and verify that signature using public key of DSA algorithm. So I will use next line here, and before taking a user input, let us give information to our users to input a string using out. Enter a message to sign digitally using DSA algorithm. So this is our first step. So in second step, we will generate a key pair, public key and private key, and we will use DSA private key to sign the user input message, and we will use equivalent public key to verify the signed message. So step 2, generate a key pair using DSA algorithm. So to generate a key pair, I'll use KeyPairGenerator class. So KeyPair generator class, KeyPairGenerator is equal to KeyPairGenerator get instance. So we will get an instance of DSA algorithm and store our key pair in KeyPair variable. Key pair is equal to KeyPairGenerator dot generate key pair. So we need to import this key pair class, and let us store our public and private key in private key and public key variable. Private key equal to key pair dot get private, and public key pair dot get public. So let us import this one as well. Import class from Java security framework. So we need to handle our exception. So let us add exception in our main method signature. So in step 2, we have generated a private key and public key. Private key is used for assigning a digital signature in a message, and public key is used to verify that sign. So in step 3, we will create a signature object for assigning and verifying the message. So to create a signature object, we will use signature class. Step 3, create a signature object for signing and verifying a message. Signing and verifying a message by using signature class, signature class from Java security package. Signature object is equal to signature dot get instance, and the instance will be SHA-256 with DSA. So we will use a hashing SHA-256 algorithm with DSA. So now we need to initialize this signature object using private key so that we can sign on a user input data. So initialize the signature object using private key. Private key to initialize, we need to use signature dot init sign method, and we need to pass the private key here. After that, we need to pass the data as well. Pass data to signature object to sign by private key. So to pass the data, we will use a method named update method in signature object, signature.update, and this method will receive byte type data user input user message dot get bytes. So this line will initialize the signature object and update the signature object with the data that is going to be signed with private key. After that, we need to generate a digital signature. So generate a digital signature of user message by using signature.sign method. So this will generate our digital signature, and we need to store this digital signature in our digital signature variable, and the type of the digital signature variable is byte array, byte array. Okay, so now we can print our signature. Digital signature is so we need to encode this byte array in a base64 format. So to do that, so I'll call a base64 encoder. Base64 dot get encoder, and we need to encode this data to string. So encode to string method will accept a byte array which is digital signature. Okay, so this will print our digital signature in base64 encoded format. Now step 4 is to verify the signature using public key. So before verifying the signature, let us run our code and let us see our signature first of our user input message. So let us run this code. So let us type a message, sign this message using DSA. As you can see, so this is our digital signature that is encoded in base64 format. So now we need to verify this signature, whether this signature is signed by the equivalent private key or not. So we'll use public key to verify this message. So let us implement that part. So to verify, we need to again initialize our signature object by passing a public key. So signature dot init verify, and we need to pass a public key here, public key, and then we need to update our data as well. Signature dot update user message dot get bytes, and verify this message by using a verify method, signature dot verify, and we need to pass a digital signature. Okay, and this verify method will return a boolean data. So boolean verified equal to, so if verified is true, then we can make sure that our signature is verified by our public key. So s out, or you can use if else condition. If verified, s out signature signature for the message is verified, else cannot verify the authenticity of a message of a user input message. So let us run our code. Hello world, please generate a signed for this message and verify it as well using its key. So as you can see, so this is the digital signature, and by using its equivalent public key, signature for the message is verified. So that's how you use DSA algorithm in Java to sign user information digitally by using private key and verify it by using public key. So thank you for watching this video. Thank you very much.